thanks.
I forgot to mute you.
Or are you supposed to just
Dead.
I don't know, I can do that. Alright.
Remember the minute around here because
Get my
Mrs.
nerds.
Donahue was a cheater, a player?
David, well, we always said this was really mistake was a terrible.
Dead.
Okay, so guys, this basically covers the 4 types of factoring that we could have, solved by factoring. Now, if you guys recall, with solving by factoring, we wanted to equal 0 first. So they must equal 0 if you're solving by factoring.
So this one's
So we had a whole chart just for this one. So like this letter B, I want to move this 20 over right away.
What?
So they all have to equal 0 in order to solve by factoring. You just want to do letter B since I started that one already?
We might as well.
Okay. So this one has 3 terms, but there's nothing in front of the x squared. So I know already that it's going to be x times x. I want to multiply to get negative 20, but add to get 8.
2 and
5 and 4.
10. No.
1.
So minus 2 plus 10 will multiply to give me a negative 20, but when I add them, they give me 8, which is also important. So then once I'm at this point, I just set each of those factors equal to 0 and solve. And obviously, you don't have to show all your steps on the solving. But on the factoring, I do need to see your steps so that I know you actually did solve them by factoring, because there are other methods. So we get those 2 answers. All right, the first one is a different type of problem because it only has 2 terms.
GCFs.
And you should always look for a GCF first, but there's no common factor between 2 and 25. So that makes us think about the other type of 2 terms. They're both perfect squares.
Wait, 4 and 25?
4 and 25.
You said 2 and 20.
Sorry, 4 and 25. There's no common factor between 2 and 25 either. But 4 and 25 as well.
I was just like confused where you got the 2.
Okay. So this is difference of squares. So 4y squared is 2y and 2y.
Plus minus 5.
And then I want that middle term to cancel, so that's where the plus and minus 5 comes from.
You got it, girl.
And it should equal 0. I just left that out. But then each of these factors can equal 0. So negative 5 halves, so negative 2.5. And then you're actually going to find out it's also a positive 2.5. And I solve each of those. So that's difference of squares. And for whatever reason, I feel like this one and letter C are the toughest ones to keep track of and kind of not get confused. So letter C is now this one's a GCF because there is a common factor among these 2 terms. What's our common factor?
Y.
Just a y. So I can pull y out and divide a y out of each of those terms. So I'm left with 2y minus 5. And now at this point, I can set each of these factors equal to 0. So y would equal 0 is one of my answers. Oh, we have the same thing over there. This other one is,
Did you plan that?
no, I think I copied the problem and didn't change enough of it.
Oh, well.
Yeah, that's fine.
It's okay, I forgive you.
Thanks. And then the last of them, this last one doesn't have a GCF, so 6, 5, and 4 don't have a common factor. So this is the kind that's that X type of factoring.
No.
We do the cross.
Got it, alright.
So I multiply this first and last term together. Put that negative 5x on the bottom. I want to multiply to negative 24, but add to negative 5.
Minus 8 plus
6 and 4.
What's that?
3. Minus 8 plus 3.
Minus 8 plus 3. And what we use those two for is we use that to split this middle term up. So the first and last term is going to stay the way it is. But I'm going to split the middle term using those two new factors. And now we're going to do grouping here. So I can take out a 2x actually probably, right? But then this one is already the same, so I'm just going to take out a 1 as like a placeholder. And now I can set each of those factors equal to 0 and solve. I get 4/3. And then a negative 1/2. My two values.
This is this all over to
Yeah, and quadratic formula is one of our big formulas we want to make sure we break down. Now, the fact that they use a's as the variables, that's kind of confusing. Remember that the a, b, and c come from the coefficients. So the formula we're talking about, this,
Oh my gosh.
this song, all over too. Yeah, yeah. The first step though, it does have to equal 0. So I'm going to move the 2 over first. And again, the fact that these are a's, that might be confusing. You can change them to x's, it's fine. The a, b, and c come from the first, second, and third term, like the coefficient. So technically in this case, the a we're talking about for the formula is 2. The b is negative 1, and then the c is negative 15. Yep, yeah.
That was Bennett?
Yeah.
I thought that was Nick.
That's what I thought.
Then it speaks. Opposite of b is 1. Plus or minus. B squared is negative 1 squared. Minus 4 times 2 times negative 15. All over 2 times 8. The two negatives and become positive. 34, so that's 120.
Yep.
So that's going to be 121 inside the root, which is a good number because it's a perfect square.
211.
So at this point, I have 1 plus or minus 11 all over 4. When I do this, I just have to make sure I'm careful about the fact that it should be 1 plus 11 divided by 4 and then 1 minus 11. So I kind of have to break them up as 2 separate problems here. So there are 2 answers there. All right, what do you guys think? Should we,
Take a break.
Well, I was gonna say, is that enough for today and just leave the rest of chapter 5 and then we have chapter 9 for tomorrow?
I think that works.
Okay.
Yeah.
Okay. So, what we're gonna do then for tomorrow is the review packet I gave you, the problems we just talked about are basically up to number 16. So, I'd like you guys to try to finish 1 through 16 for tomorrow. And then the rest will be for Thursday. Plus maybe a little bit more with chapter 9. So I might have like a little additional. So 1 through 16 for Tuesday. Okay. Thursday.